Good day, grade 12 learners. Welcome to today's technical mathematics lesson. My name is Moses Maudu. This lesson is brought to you by the Department of Education, Gauteng Department of Education, in collaboration with Pagama Research and Development. Today we're going to be looking at integration, which on the slide there is differential calculus and integration, but we're already done with the differential calculus. So then we're going to be looking at integration, which is plus or minus 15 marks in an exam. So it's plus minus 15 marks that we're going to be looking at. Now, with differential calculus, the marks that will be in a paper will be plus minus 50 marks. So the integration part is the one that we're going to be dealing with today. Now, obviously, at the end of the lesson, this is what I want all of you to understand or to have learned. You should be able to understand the concept of integration as the summation function, which is a definite integral. We must also know that integration will be a converse of differentiation, which is indefinite integral. Now, we need to also be able to apply the standard forms of integrals. So we'll be looking also at that as a converse of differentiation. Remember, integration is just a reverse of differentiation. So you see when we do some activities what I'm talking about. We need to be able to integrate the following functions. So you'll see the rules there. How do we integrate that? How do we integrate that? And this is also very, very important that you should know that our a value must be greater than 0. If I've got an a here, must be greater or equals to 0. My k value there and the a value must be element of all real numbers. Right. The other one is that you must be able to integrate polynomial consisting of terms of the above, the ones that we were talking about in the previous slide. We need to also be able to apply integration to determine the magnitude of an area. So remember, when you have an area which is included by the curve and also the x-axis, or by the curve, the x-axis and those coordinates will be coordinates of x equals to a, the coordinate of the other x will be equals to b, and the a and the b must be an element of integer. So in other words, we need to understand that we're going to be looking at the area which is formed between the curve and the x values, the x coordinates there. Now let's look at the mind map of integration. All the things that I've been talking about there, we need to understand the concept. What is it all about? We need to be able to apply the standard forms of those. We need to be able to integrate the polynomials given. We also need to apply integration to determine the magnitude of an area. Those are the 4 things that we need to be looking at. We must understand this concept. What is it that we are doing under integration? How do we apply the standard forms of the integration, and how do we integrate polynomials? Then how do we then apply the magnitude area of that? Now, if you look at the slide here, obviously each and every topic has got its own terminology. In this case, in integration, these are the things that we need to know. We need to know what is integration. You're not going to be asked in an exam that you must define integration, but you must just know what it is. There is a method of adding and summing up parts to find the whole. So when you look at the area, then you'll see what we're talking about. We have what we call the definite integral. You'll see this word more often, and the indefinite integral, you will also see this word more often. This is the integration that contains the upper and the lower limits. We'll show you that. So in other words, if I've got the sign for integration and then I've got the upper limit and the lower limit, that's what we're going to be talking about. Indefinite is defined without the upper and the lower limits. So it's indefinite if it doesn't have the upper limit and the lower limit. We have the integrand, which is the function being integrated. So when we show you the integration, you'll be able to understand what we're talking about. Now, remember in mathematics, technical maths, and all the maths, we have what we call we have reverse processes. For instance, if I've got a plus in addition, the reverse process will be a subtraction. If I've got multiply, then the reverse process will be division. If I'm doing exponents, the reverse process of exponents will be logs, and this is what you're doing also. So in calculus also and integration, the reverse process of differentiation, which is differential calculus, it's integration. So in other words, it's sometimes called the antiderivative. So this way also you're going to see that more often. Antiderivative, meaning that you're going to have, if I've got a sum, when I need to differentiate, I can take that sum back by using integration to the one that was given in differentiation. For instance, here is an example. In differentiation, we know that if f of x is given as 2x squared, and I hope everybody now understand how to differentiate. We've done that topic in term 1. So if I want to differentiate that, so I take the 2 multiplied with a 2, so it gives us a 4. Then I subtract 1 here, so which is going to be 4x to the power of 1. Now we say the integral of 4x. So in other words, what we're going to be doing is to take that one back to this one. So we're going to show you how we're going to do that. So the integral of 4x, it's equals to 2x squared. The notation that we're going to use for integral is the stylish s. We call it the stylish s. So the sum, this has nothing to do with that. This is that sign here looks like s, which is the sum, or the idea of the summing of the slices. Okay, so we'll show you when we're also doing the area what we're talking about. So here is the sign of that integration. So that sign is the integration. This is what we are going to integrate, the function that we're going to integrate, and there we put dx, which is called the slices along the x-axis, right? And this one is an integral symbol. So we have got the function that we are going to integrate, which is the integrand. So we take this, we then have to find the integration of that 2x. So we are integrating. So with differentiation, remember, we have the dx over the dy, or we have the f prime x, then we are differentiating. But with integration, we have its own symbol there, then we use that symbol to integrate. Now, look at this. Now, if we differentiate the following, if I take all this and differentiate them, what will happen? Notice this. If I differentiate this, remember the differentiation of a constant is 0. So if I differentiate this, this is 2 times 2, it's 4, minus 1 is going to be 4x. The differentiation of a constant 1 will be 0, so it will be 4x plus 0. If I differentiate this, I'll still have 4x, and the differentiation of that is 0. If I differentiate this one, is going to be 4x, and this is a constant. The differentiation of constant will be equals to 0. Therefore, what do I notice here? I notice that all these 3 functions that have been given there, then it always gives us 4x when we are differentiating. So when I differentiate this, I always get 4x for all these 3. All right? So what is the integral of 4x? And that's what we're going to be looking at again, to say, if I integrate this 4x, which one of these 3 will I get? Will I get this? Will I get that? Will I get that? And you can see that is a constant, so I'm going to have a problem with a constant. And we'll talk about it when we do activities. Now, these are just the fundamental rules of integration, the general solution of that. So in other words, if I've got this, You see, it's x to the power of n. It's an integrand. So in other words, this is the sign for integration. So where n is the constant and n is not equals to -1. So how do we do then this one? So look at this. So we're going to say, when we integrate, we have this, we need to integrate it. What do we do? On the n here, we add 1. Remember, when we differentiate, we subtract 1. But when we integrate, we add 1 on the exponent. So it's n plus 1. Whatever we have added on the 1 here, we take that whole thing, then we put it as a denominator. So in other words, we have x to the power of n plus 1 divided by the n plus 1 there, we put it as it is in the denominator, which will then be the same thing, x into n plus 1, all divided by n plus 1. This is the integral of x to the power of n. All right, so now let's look at this when the x of n is multiplied by the a. Oh, the other thing there, we need to plus the c. Why are we plusing the c here? It is because we don't know what is that value like we did in the previous one. The other one was -1. The other one was +3. The other one was pi. So we don't know. So if we don't know what that value is, then we add the plus c there. So that is why we're dealing with the indefinite integral. So we'll add a c. The c will be an element of all real numbers. Okay? So in other words, we're going to have a plus c there, which is then an element of all real numbers. So you'll realize that when we have an indefinite one, because there we don't have the upper level and the lower level, then we're then going to plus a c. So that c means that there's a constant that we are missing in there. So now, what about when we are multiplying the x of n, x to the power n by a? So we'll have the same thing. The a is a constant value, is that a coefficient? We say x into, then it's n plus 1. Whatever we have there, we divide it by that thing there, which is n plus 1. Okay, and that's how we integrate. So integration is quite easy. The reverse of differentiation. Remember, in differentiation, we multiplied by the coefficient, by the exponent, and then we subtract 1 from the exponent. So in this case, what do? We add on the exponent plus 1. Then from there, we divide by that answer that we get on the exponent. Now, let's look at the activities, easy activities. This is the easiest of them all. So we're just going to apply that rule there. So let's quickly try to apply that rule. Remember, when you integrate, the integral sign falls off. The same as we are differentiating. When we differentiate, the the f of x falls off. Okay, then it becomes, right, so f prime x. So in this case, when we differentiate, once we start integrating, the integral, the sign falls off. So in this case here, I'm just going to start integrating because I don't need to do anything on that integrand. So in the x to the power 3, I don't have to do anything. So what am I going to do? I'm just going to write equal sign, and from there the integral sign falls off. So I'm now going to write x. What do we do with the exponent? You can see now you know how to do it. It's 3 plus 1. We are adding a 1 on the 3. What do we do on the denominator? We take 3 plus 1, we put it there as it is. Then we can then quickly write down the answer, which is going to be x to the power of 4 all over 4. All right. So that is the integration. This is how we integrate. So integration is quite very, very, very easy. If you want to take this one back, if I want to take this one back, let's say it's f at x it's equals to x to the power of 4 all over 4, integrand of that. If I want to take it back, integrate it, differentiate it, then what am I going to have? 4 multiplied by this. Remember, when we integrate, we multiply that. So I'm going to have 4x, subtract 1 there, we're going to have a 3, then all over 4. That one falls off, and then we have x to the power of 3. And that is what we need to integrate. So in other words, we can be able to move from this step to that step. Then we can move, we can be able to integrate. This is when we are differentiating, right? So this is differentiation, right? And that is integration. So this topic that we're doing now, we are doing that now. We're taking this thing here to where to the one that we can differentiate. Okay, 1.2. What is the integral of 5? Remember, these are the slides. So we always have to, you'll always have the dx everywhere. So what do we do in here? Remember, we are going to add 1 on the exponent. Remember, what are we integrating? X. The slices are x's. So what do? I have a problem here now. I do not have an x in here. What should we do now? As long as I have not integrated, that side must come in. But I must make a plan if I do that and put this one to the power of 0 and the dx. I'm still going to get the same thing there. Why? It is because x to the power 0 will be 1. And 1 times 5 will give us a 5. So I must make a plan to get the x there. So what am I going to do now? I'm now going to integrate. Once you start integrating, the integral sign falls off. So I'm going to have 5x 0 plus 1 all over 0 plus 1. Right? So therefore, I'm going to have 5x to the power of 1 divided by 1. Then the answer there will be 5x. So if I take 5x and then differentiate it, I must get 5. Okay, so that's how we integrate. So every time when I want to integrate, that's what I'm going to do. In 1.3, I'm going to do the same thing. So I'm now going to say, if I've got integral to integrate 5x of dx, I'm going to do the same thing. So in this case, the x is there, so I don't have a problem when the x is there. So I'm going to say this is going to be 5x, it's to the power 1, remember? What do? We add 1. According to the rules. Then what do we have there? 1 plus 1, it's 2. So I can just write it 1 plus 1 as it is. Then from there, what am I going to do? 5x squared all over 2. So my answer will be 5x squared all over 2. If I want to differentiate that, 5 times 2, it's 10. 10 divided by 2, it's 5. Subtract 1 there, I'm going to have x to the power of 1. So that's how I can differentiate it. So in this case, I'm integrating. So once you see that sign there, it means that you are integrating. And these are called indefinite integrals. Reason? It is because there's no lower level, there's no upper level. So if I've got a number up there and a number down there, that will call it definite, but we'll do them later on. Right. (1.4). Now we've got a challenge here. Now we need to integrate this one. we've got 2 over x squared. Remember, you're basically doing the same things as you've done in differential calculus in terms of simplifying. Because remember, in differential calculus, when we have something that is the x, which is a base, what do? Remember, that's exactly what we're going to be doing here. I've got 2 over x squared, and x squared is the denominator. So that denominator there, it's x squared. So I must use my exponent. So exponents are very, very important. And also your basic algebra, whereby you need to multiply brackets, where you need to get, you need to divide everything there by x, for instance. It's very, very, very basic. So in this one, integral of that, I must first simplify that. Before I do that, then I'm still going to retain the sign because I want to simplify it first. So I'll have 2x to the power minus 2. Remember, in exponents, if I've got 1 over a n, this is the same as a to the power of n. Note that. So if that is a positive n, I take it up, it becomes a to the power minus n. If I've got a 2 over there, the 2 will still remain there. Okay, so that's what I've done there. So this is just the basic thing that we do in exponents, and it's a law in exponents, right? So now in this case, now I can then be able to integrate. Now for me to integrate, I'll have 2x. I've got minus 2. What should I do on top, on the exponents? Plus 1. We must always check what is it that we are working with. Which slices am I working with? Now I'm working with the x slices. So therefore, what do I have at the bottom? Minus 2. What do I have there? Plus 1. So I'm going to have 2x to the power minus 1 divided by minus 1. And to write this property, I can have it as minus 2x to the power minus 1. In some cases, they might say, write it as a positive exponent. So which means I can write as a positive exponent, the minus 2 will remain divided by x to the power 1. Remember, if I take this one down there, because it's over 1, if I take it down there, then it changes the sign of the exponent. So it's minus n, so it will be positive n. So I can either write it this way or that way. You will still get full marks, unless if it's stated that you need to write as a positive exponent, you must stop there. You cannot stop here, so you need to stop there. Okay, because we're just reversing this rule that we have. We're reversing it back to this. Okay. All right. Now let's look at this indefinite integrals, where we're going to be working with, some functions, hyperbolic functions. Now, for instance, here, the hyperbolic functions. We have done hyperbolic functions. Your functions where you have your a over x, right? Y is equals to a over x, which is your hyperbolic function. So when you're dealing with hyperbolic functions, it's very different. These rules, you must know. These rules you must know. They're very, 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 very important. Right. If I'm given f of x equals to x to the power minus 1. Remember, if I take that and I want to integrate it, for instance, if I've got this and I want to integrate it, I have x to the power minus 1 of dx. I want to integrate this. So I'm going to have x to the power minus 1 plus 1 all over minus 1 plus 1. In this case, then it gives me x to the power of 0 all over 0. Oh, now I have a problem. Dividing something by 0 there. See, division by 0 is not allowed. In technical maths, we cannot divide by 0. Alright? So It means that then we need to make a plan. We need to make a plan. We cannot integrate that. So we need to make a plan. What is the plan? The plan is to introduce something called ln, which it talks to the logs anyway. So which is ln. Ln. That's what we are going to be writing. So how do we write this? We are now going to have, if I've got 1 over x, I already know that is going to give me a division by 0. So what should I introduce? We introduce the ln. So the ln, so this is how we write it. Ln, we can write brackets here, is the absolute value actually. The absolute value, because you remember the logs do not work with negative numbers. So it's the absolute value of that value, of the number that is there. Then obviously we are going to include the c. Remember, every time when we integrate, we are going to have a c, plus c. If I did not put it on that place, make sure that when you integrate indefinite integrals, we need to put plus c. So where c is an element of all real numbers. So in this case, 1 over x, I'm now going to put ln of x, right? If I've got that value of k there, multiplying with x to the power 1, this is the same as k over this. So I can write this one as k multiplied by 1 over x. Obviously, that thing there will be ln of x. So you can see there, the k can also be taken to the back of the integral sign. Then this one will be the ln of x. Then from there it's multiplied by that k. So if I've got a 2 here, it will be ln of x, and then from there plus c. We can still put brackets in there. All right? These two rules are very, very, very important. We must learn them and know and understand them. Now, let's look at this one activity here. Right? So you've got 1 over 2x. Once that x here, can you see that x here is to the power of 1, then we have a problem as a denominator there. Because if I take it up, it's minus 1 plus 1 gives us 0. And we're going to be dividing by 0, which is incorrect. Right. I can write this properly here. So I can have integral sign 1 over 2 multiplied by 1 over x. Already I've got a problem here, right, of dx. See, already once I have 1 over x, then I've got a problem. But it's an easy problem to solve. So from here, I can take this to that side. It doesn't matter. You can still put it there. We can do this and say half integral sign 1 over x. Then we just integrate that. So remember, this half there will still remain. So when we integrate, you are going to have 1 over 2. Then what am I going to have? Ln x. Then that will be plus c. Remember plus c. We always forget that c and then we lose a lot of marks on there. Right, so I can write it like this, or I can write it as the whole thing divided by 2, so it can be ln of x over 2 plus c. The same thing, obviously, the same thing. Just there's a 1 here, there's a ghost 1 here, so it's 1 over 2. So that's the 1 over 2 there. So it's the same thing. Okay. So it is very, very important that we understand how to apply this one, especially with the 1 over x. I'm going to show you another one again, which has an x as an exponent. Right. Now, the next example there, this one looks very, very, very easy. It looks very easy there. This is a constant, so that is not a problem. There is a constant. So what we have is that constant. How am I going to write that one as a constant? So I'm going to write equals to. Immediately with this one, it's easy. I can just write equals to, because there's nothing to do, there's nothing to fix there. I can just write this equals to. Then from there I integrate that x squared plus 1 over 2 plus 1 minus, so I integrate this each and every one of that, like you're differentiating. So 1 over x, remember 1 over 4 is a constant, so it's the same as x to the power of 0, so which is the same as plus 1 all over 0 plus 1, right? So that will give me x to the power of 3 all over 3 minus, so this will be 1 over 4, x 0 plus 1 is 1 over 1, so I don't need to write 1 over 4 over 1, so I can leave my answer like that. But what I must not forget is plus c. So in most cases you'll find in an exam they will penalize you for not writing plus c, so make sure that you don't lose that mark. It's just plus c, that's all. So you must just have that plus c in your answer. So that answer will be x cubed minus 1 over x plus c. Right. The next question, very, very important. We must always check this. The integral of 3xy. What are the slices there? The slices are for x, not for y. So the slices are for x. So meaning that I must just work with an exponent of x. In this case, the exponent of x is 1. I don't worry about the y. So the exponent of x is 1. So if this question was 3xy dy, I'll only work with the slices of y. Then I work with the y. So in this case, the slices are for x. So it's very important that you look at what is written there. So sometimes they write dp when we have a p in there. So you only work with the exponent of p. So what do we do in this case? So we're working with the exponent of x. So it's 1 plus 1. The y, we don't worry about it. Divided by 1 plus 1, because we're working with this one only. So therefore I'm going to have 3x squared y all over 2, and that's how I'm going to do it. So obviously if I'm differentiating, if I differentiate this and differentiate with respect to x, it will be 2 times 3, which is 6, and then from there, if that one is 6, we subtract 1 there, we get an x. And then 6 divided by 2, it's 3, we get 3xy, which is this one. So obviously from here, I can go back here, right? And that is, don't forget, it's plus c. All right, so that is plus c. Obviously the constant will be a bit of a problem. So we really need to know what the value of c, because this is indefinite integrals. The value of c going back might be a bit of a challenge. Okay, right. So now we are going to look at the one way we are going to integrate the polynomials. It's still indefinite. Indefinite meaning the upper value is not given, the lower value is not given. You see when we have upper value given, lower value given, how easy that thing will be. Now in this case again, first of all, I must simplify. We cannot do that question without simplifying. So we need to simplify. My slices are x. So in this case, 2x minus 1 multiplied by 2x plus 1. I must first simplify. If I don't simplify this, I cannot be able to find the correct integral of it. When I'm simplifying, the integral sign will always be there. So I first simplify, the integral is there. Now we multiply 2x multiplied by 2x will give us 4x squared 2x multiplied by 1 will give us plus 2x. Minus 1 times 2x will give us minus 2x. Negative 1 times positive 1 will give us negative 1. The dx is still there. I still keep my integral sign because I need to simplify this. So I'll get a 0 there, 4x squared minus 1, close bracket, the dx is still there. Now the next step is now to integrate. Once I start integrating, I remove the integral sign. See, I'm repeating that you must know that you must always remove the integral sign. So I'm now integrating. So I'll have 4x squared plus 1 over 2 plus 1 minus, remember this is x to the power 0, so it will be 1 times x to the power 0 plus 1 all over 0 plus 1. Then I'm going to get 4x power 3 divided by 3 minus x to the power of 1. So that integration is done. So I've integrated that whole thing, which is not complicated. So you can imagine if I want to integrate and integrate this one and that one separately, I'll have a problem. Okay. All right, this answer I'll never get. So this is the correct integration. Okay. This looks challenging, but not. Multiplying out, your exponents must be known here. How to multiply? When I multiply exponents, what do I do with those negative 2's? Okay, so now in this case here, first of all, I'm not going to integrate things like that. I must first simplify it. So the first thing that you need to do there is to simplify. Right? So now how do I simplify this? Write your integral sign. This multiplied by that will give me x to the power minus 2. Same thing. This one multiplied by that will give me a negative x to the power negative 2 plus negative 2. Remember, we are multiplying same basis. We add the exponents. So it's minus 2 must give us negative 4. Then 1 times 1 is plus 1. Then 1 times this will give me a negative x to the power minus 2. And we have a dx. See, I've not integrated. What I did was to simplify. Then I'm simplifying further. I will have the x to the power minus 2 minus x to the power minus 2 will give me 0. Then what am I left with? Negative x to the power of 4 plus 1. That's what is left. Right? Because that will give me a 0. Now, in this case, I can now start to integrate. So I'll have, once I integrate, remove the sign of the integral. Negative x, this is 4, so this is minus 4, sorry. This is minus 4 plus 1. So that is divided by minus 4 plus 1. When we are still practicing, I want us to do that so that then we know where this one comes from. I can write minus 3, but when you don't know where it comes from. So this one at the bottom here is the same as that one with the exponent. So when you're practicing, start by doing that, and when you are used to it, then you know that you are adding a 1, so it will be minus 3. Then that will be plus 1x to the power 0 plus 1 all over 0 plus 1. Then we are going to get negative x to the power negative 3 all over negative 3 plus 1x. Right? So I can write it properly here. So negative and negative divided by negative is a positive. So I'll have x to the power negative 3 all over 3 plus x plus c. Right? Once I've done that, what can I do now? I can either write it as a negative positive exponent. So I'll have 1 over 3x to the power 3 plus x plus c. So I can either write it in that form or I can write it in that. So I can write it in any other form. Okay, so this form is still fine, that form is still fine. This one will be fine if they say write it as a positive exponent. You can see we don't have any x as a negative exponent, so everything is positive exponent. So that could be correct. All right. Now in 3.3, the integral of x squared, x to the power minus 2 plus 3 to the power of x. Now I have a problem here. I've never differentiated something like, integrated something like that. 3 to the power of x. I've been integrating it with numbers, minus 2, minus 3. Remember that value there, the 3 to the power of x is an exponential function for that. So how do we differentiate exponential function? And this is how we're going to do it. Now, for us to differentiate, first of all, it's fine like this. So first of all, I need to understand how to differentiate an exponential function. So if I've got a to the power of x, and I want to differentiate this, integrate this. So what I do is, please, you must know also this rule. I'll put a to the power of x. I'll then divide this. This is a rule. So I'm going to divide this. I can put an n there, it doesn't matter. I can put an n there, it doesn't matter. Let me put an n. Right. For instance. So what am I going to do here? I'm going to say a to the power of n. At the bottom, I must write ln of a. And this rule you must know. Alright, so in this case here, I can quickly now integrate. So how am I going to integrate this? So I'm going to say, this is going to be x to the power of minus 2 plus 1 divided by minus 2 plus 1. Once I see an x as an exponent, or whatever the slices are as an exponent, then immediately I write, this is a plus sign, immediately I write 3 to the power of x divided by the ln of that number there, of 3. And that is how I'm going to write that. Okay, you'll see when we substitute, when we're dealing with definite integrals, that you go to the calculator, you place it, you substitute it correctly, you're going to have correct answers if you substitute it correctly. Right. So now when you have the upper one and the lower number. Now in this case here, I'm going to have x to the power minus 1 divided by minus 1 plus 3 to the power of x all over ln of 3. Right? So in this case, I'm going to have negative x to the power of negative 1 plus 3 to the power of x all over ln 3. Now, I don't like it like this, when we have a negative and a negative exponent on the other one. So, yeah, story of my life. where I don't like now negative exponent. So therefore I can say negative, this negative will remain here, 1 over x to the power 1. So I just take that rule and then just reverse it, then plus 3 to the power of x all over length 3. That will be plus c. Don't forget the c. It's very, very, very important that we always remember to put the c. Sometimes I do forget that, you know, but please do not forget in the exam that c must always be there. Maybe before you write your answer, you must put plus c, and you know exactly that, oh, no, I have c there, that must be there, if this is an indefinite integral. Okay. 3.4. Now again, here we're having negative 6 over x minus 1 over 2 pi. Already I know that this one, it's my constant, because my slices are talking about a x, and this one does not have an x, right? So it's a constant. Right. Dealing with a constant when we're working with integral, remember we just put an x. But now we have this one here, which is a bit of a the challenge here, but I can work with this. So what I can do here first, the integral, I can put negative 6, I know it's negative 6 over 1, multiply by 1 over x. Obviously, if I multiply this, I'll get back to this, minus 1 over 2 pi. I'm just going to put this in bracket. Slices is dx, is the x's. Now, immediately I can see here I've got 1 over x. So what do we know? 1 over x is ln x. So I'm going to then integrate. So I'm going to have the negative 6 will remain. This thing there becomes ln x. Done. So with that part I'm done. With that one I'm done. So once the x has got an exponent to the power 1, if it's x to the power minus, if it's x to the power 2, for instance, then that one I can work with. But once it says x to the power 1 as a denominator, then I know, oh, there's something that I must do there. Remember, this one is the same as the one of k. Now, there we're having 1 over 2 pi. I've got an x which is to the power 0. So it must be plus 1 all over 0 plus 1. So my answer there will be negative 6 ln x minus half pi multiplied by x. That is plus c. That I always forget. But this time I remember. We must have a c plus c. When you are dealing with indefinite integrals, it's plus c. Okay, right. Now, we are now going to do the definite integrals. But before we do the definite integrals, the properties of that, we are going to take a quick break for 2 minutes. Right, welcome back. Now let's talk about, we're talking indefinite. Now we're talking definite integrals. Now definite integrals, this is what we're talking about. Now you can see on the integral sign we have the upper value and the lower value, the a on top, the b at the bottom. Then you have got the integrand here and the slices there, the d of x. So in this case, if I swap the values, the b goes up there and the a comes down there. Therefore, that whole thing there becomes negative. So we must put it negative. But I don't want us to go there, because then I want us to always put the bigger number on top and the smaller number at the bottom, which makes it easy for us to get the correct answer. Because once you swap them, you forget to put the negative, the answer becomes incorrect. So let's put the top one, the bigger number on top, the smaller number at the bottom. Then we can then integrate easily there. So the integral of the sum or difference of integrands in this case is the sum of the integral. So in other words, if I've got the integrand, the integral of that plus minus the integral of that for dx will be the same as the integral of that plus the integral of that. So if I've got this thing in here done together, so I can integrate them separately. So I can have this over that. Okay, so you can see this is b, 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 a. Okay, so you cannot come here and swap this one over that and swap the other one to a and b. So keep them constant like that as it has been given. Okay. All right, now let's look at the examples of this. Evaluate the following definite integrals. So which means I've got the upper number is 2, the lower number is 1. In other words, it's nothing else but, having a straight line graph. Then from there, let us get the area between there. But when we do the area, then I'm going to show you in a graph what I'm talking about. So which means here, in this case here, we've got a 2x. We're going to do it the same way. We are going to integrate 2x. Remember how to integrate the 2x? Let's go for it. How do I integrate 2x? So I'm going to first do this. I'm going to first integrate 2x. If I integrate 2x, I get 2x 1 plus 1 all over 1 plus 1. Then, because I'm integrating, I must put the square bracket. The bigger number 2 is on top as it is given there, and the smaller number at the bottom. Please, 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 once you integrate, you're going to put these square brackets and put the 2 and the 1 in that form. Then I have my integral there. I'm going to have 2x squared all over 2. Still keep that 2 and a 1. Then I'm going to have this divides into that. So I'm going to have x squared. My integrals is 2 and 1. Please, please, my boys and girls, this does not mean that it's x squared all squared. It does not mean that. It means that we first need to substitute by 2, then we substitute by 1. So what we're going to do here is, I'm going to now then do this. The first bracket there will be substituted, the x value must be substituted by 2, and and I say minus, we always subtract the top, the bottom from the top. So I'm going to say subtract the one where we substituted by 1. So here first I'm going to substitute by 2. So I'm going to say 2 squared. It's 2 squared. Then what am I going to do on the next bracket? I'm going to substitute by 1. So it's going to be 1 squared. Then I no longer put the 2 and the 1 and all that. Okay? So therefore I'm going to have 2 squared is 4. 1 squared is 1. the answer is going to be 3. I'll explain what is the 3 when you do the area. Okay, so with 4.1 we are fine. Okay, that should be the easy one. So I've taken this one as the easy one, so that when you go to the complicated ones with the area, then we are able to understand what we're doing. Okay, right. In 4.2, the upper value is 3, the lower value is -1. And it's a 3 here. So when you do area, you'll see the picture, and then I can show you in the picture what we are talking about when we talk about this. Okay. Now what do we do? Obviously, first thing you're going to integrate. I integrate 3x to the power of 0 plus 1, if it's a constant, divided by 1. This whole thing there must be inside the bracket, and a 3 on top and a -1 at the bottom. Then I'll have 3x, right, to the power of 1, divided by 1 is 3x, and this thing here, we have a 3 and a -1. Once you have done that, then what do? You put 2 brackets here, minus this bracket minus that bracket. Then the first x must be substituted by, in the first bracket we must substitute by 3. So we're going to have 3 multiplied by 3. In the next bracket I substitute by -1. So I'll have 3 into -1. Then 3 times 3, it's 9. Then we have -3, because this one will be -3. -3 is +3. Then 9 plus 3 will give us a 12. Right. Okay, that's how easy it is. So there's not difference. The difference between indefinite and definite is that we have got the upper level, the lower value. Okay, so the upper value and the lower value. So you can see now we no longer write plus c because it's definite. We need to substitute those values by 3 and -1 in that case. Now with 4.3, we are going to work in the same principle that we are first going to integrate. So the integral of that, by now I hope everybody understands how to get the integral. It's 3 plus 1, it's 4, so it's going to be x to the power of 4 divided by the 4 that is there, we put it underneath there, so it will be 4. Okay, so therefore we'll have this, and then from there it's 1 and -1. Okay, so it's x to the power 4 over 4, then it's 1 and -1. So what do we do here? We substitute first bracket minus that bracket. Then I'm going to have 1 to the power 4 over 4. Right? This side I'm going to have -1 over 4, -1 to the power 4. Then in this case I'm going to have 1 over 4 -1 to the power 4, it's 1 over 4. My answer there is going to be 0. 0. So we're going to have a 0. So which means that from this point, when I subtract those two, I get a 0. But when you do the area, it will be very different. You'll see it when we do the area, that this thing there becomes, it is very different. The answer is going to be different when we're doing the area. But if I'm just told to integrate, the answer will be 0. When you do the area, remember, area can never be negative. So I'll show you when we do the area there. Okay, interesting one, where we have the limb now. Now we have my favorite one, which is the limb. So which is 1 over x. I've got 1 over x, so I love this one because it's very, very, very easy. So first of all, I'm going to integrate. So I'm going to integrate. When I integrate, what do? I put brackets. Right? So the integration of a constant will be that x. Remember, the x is the slice. Then that one will be plus. Once I see 1 over x, what do I know? Ln of x. Done. So I've got a 2 there and a 1 there. Okay. Get a nice mark there. Now, let's listen carefully. Then the next thing there is to have my 2 brackets minus. Right. So I'm going to have the first bracket. I'm substituting the value of x by 2. So I'll have a 2 plus ln of 2. Right. That's what I write, because I'm substituting the value of x by 2. In the next bracket, I must substitute by 1. So I'll say 1 plus ln of 1. Then I go to my calculator. Very important. I go to my calculator, I press. So in your calculator, you must then, when you're doing differential calculus, you must always locate the ln, ln, ln. So if I go to my calculator and say 2 plus ln, immediately when I say ln, then it opens the bracket. I put the value 2 there, close bracket, and then I get my answer. So my answer, correct to 3 decimal places, is 2,693 and all those values. Minus, then I go to that next bracket and I say 1 plus ln of 1. Then close bracket. Then I get my answer. So my answer is going to be 1. Then I subtract the 2, I'll get 1,69. That is the answer. Right? I can do the whole thing by using brackets. I can just put 1 open bracket, 2 plus ln of 2, close bracket, minus open bracket, 1 plus ln of 1, close bracket, write the final answer. I don't need this step here. I don't need it. So I can just do it once on a calculator, and then I get to the correct answer, which is a minus 1. So same applies when I have 3 to the power of x, ln of 3. I'll do the same. I just substitute the value of x by the value there, and then from there I go to the ln of that. So I'll get the final answer. Okay. So the one where we have an x here is the one where we have 1 over x. So when we have 1 over x, it will be the ln of x. When we have 3 to the power of x, 2 to the power of x, 5 to the power of x, then we put ln of their base. Okay, so it's the ln of the base. Okay. Now let's look at the area. Now the magnitude of the area included by the curve or by a graph and the x-axis, where the x-axis, obviously you'll be given the 2 values of x. Now we use the properties of definite integrals. We cannot get the area if we are using indefinite integrals, because remember we've got plus c. So if we need area of that, we use definite integrals with the upper value and the lower value. Right. If I'm asked to evaluate a definite integral without explicitly asked to calculate the area, then proceed to evaluate that without any concern about the answer. The value can be 0 or a negative value in this case. So let's check the second one. The second one says if the answer of a definite integral is negative, it implies that the area is below the x-axis. So if, for instance, I'm calculating the area, I get negative 12, for instance, then I know that that area is below the x-axis, right? If it is positive, then it will be above the x-axis. Now, if the answer of a definite integral is 0, it implies that it is how many parts? 2 parts. Remember the one that we have done there that gives us a 0? X to the power 4 over 4, we substitute by 1 and minus 1, it gives us a 0. Therefore, it means that if I'm talking about the area, then the area is going to have 2 parts. So in other words, I must add the 2 parts. Those 2 parts must be symmetric, okay? Hence, one must calculate the area separately. and finally add the two parts. So we do that question later on. Right. The magnitude, here's an activity, the magnitude, here, this is what I'm talking about. The graph that is here is the graph of x squared plus 4x. The question states that we need to find the area enclosed between. So in this case, you'll be given a sketch, and that sketch will indicate that area between those values. Where the curve, this is the curve, and the x-axis, this is the x-axis, where x is between 1 and 3. So here is the 1, here is the 3. Between 1 and 3. Meaning that we've got the upper and the lower. This is the area. Now, in this case, for me to calculate the area, if I don't understand, I don't know integration, and I want to calculate the area of that. So in other words, I must calculate in parts. Now it means that if I want to calculate the area of that, I must then do some some rectangles in there, you know, and from there, or the very small rectangles in there, and get the area of this rectangle, area of that rectangle, and I add them all together. And that will take me forever. And sometimes my area will not be as, you know, as accurate as possible. So for me to make to get the area of this part here, I use integration. The integration, it's the easiest way of getting the area of a curve with the x-axis without doing all those triangles, and from there I must measure that line, measure here, calculate the length times the height, and from there the length multiplied by the breadth, the length times the breadth, the length times the breadth, and I add all of them. That will take me forever, but look at how we can do this quick. So now I've got the upper and the lower, I've got the integrand. So what am I going to do? I'm now going to write down my integrand. So from there, the integrand is x squared plus 4x. That's dx. The upper value is 3, the lower value is 1. The upper is on my right, the lower is on my left. I need the area between these two values. That area enclosed here. Then from there, what do we do? Then I'm going to get I'm quickly now going to get the integral. What is the integral of that? It's x to the power of 3. By now we must know now. X to the power of 3 over 3. What is the integral of that? Plus 2x squared. Remember we added 1 here is 2 divided by 2. Then it will be 4 divided by 2 is 2. Once I've done that, what do I do? Remember, two brackets. We subtract. Right? Then we're now going to substitute the x value here by 3 first, because the 3 is the top one. So I'm going to say, instead of x, I'm going to write 3 to the power of 3 divided by 3. Working with the 3's here. Plus 2 open bracket 3 squared. In this side, on the side, I'm going to then substitute by 1. So I'm going to say 1 cubed over 3 plus 2 times 1 squared. As I said, from here you can then quickly use your calculator to do everything in there. So 3 squared is 27 over 3, it's 9, and then from there we're adding that. So from there we're going to subtract that other value. So if I do all this, the answer should be 74 over 3, or it must be 24,67. Right, remember this, now we are talking area, so it's finding the area. So that's why we are putting units squared. Right, so you must always put your units, so your unit squared must be there. Right, don't forget to do that. So The first one substituted by 3, the next one substituted by 1, because the part there. So meaning that the area of this part, it's approximately 24.67, approximately that value. Okay, right. So in the next activity, it's a very, very, very nice activity here, but it has got a lot of work to do. Why I say we have got a lot of work to do here, it is because the area has been given. Now that has been given, it's fine, but we are only given one value here. From here, remember we need the area of the shaded, right? Can I be able to get it? This is a right angle triangle, but what do I need? I need the length of that, which is b plus 1. I need the length of this one. So if I don't have the length of that and the length of that, I'll have a problem, because for me the area has already been given. So if I take length, because this is the y value, and I take length, but in this case they said calculate the upper limit of the definite integral in the shaded area. So which means I need, the area has been given, so which means I must make a plane here. My plane will be first to write down the integral. They need the upper limit. So in other words, my upper limit here is this value. Can you see? That's my upper limit, the x value. So the x value of the upper limit is b. The lower limit is -1 of the integrand is x plus 1 d of x. But they said the area, this whole thing, that area gives me 8 square units. Right, so the area is there, so I don't think I'll have a problem with the area is there. So what I need to do first now is to integrate. Going to integrate now. So if I integrate this, I'm just going to put that. I'm integrating. So the integration of that will be x squared. By now you know how to integrate. Plus x. Now the upper one is b, the lower one is -1. So the next step here is to, remember this is 8. Now the next step here is to substitute the value of b on the x. But I need this minus this, it's equals to 8. So I'm going to have the upper one is b squared over 2 minus b. I've substituted the first one by b, done. Then substitute by -1, so I'm going to get -1 squared over 2 minus into -1. That is equals to 8. Please don't put equal sign there, then you have got double equal signs. So from there, because I've already have an equal sign for the area, because that whole thing there must give me the area. So I'm now going to have b squared over 2 minus b minus a half, because -1 squared is 1, negative times positive is negative, negative times negative is positive, times this negative, it's negative. That's positive here, so I'm substituting by -1. Was it a plus there? I think there's something, okay, that's a plus, sorry. That one is a plus, that's a plus, so that's a plus. So therefore that should be give us +1, and that will be equals to 8. So I'm going to have b squared over 2 plus b. If I add all those numbers, so I'll have 8 coming to this side. So I'll have a half here, I'll have a half, and then I'm going to subtract an 8, so I'm going to get a 15 over 2 equals to 0. Then I can multiply throughout by 2, I'll get b squared plus 2b minus 15 equals to 0. Then I can get the values of b there by factorizing or using a formula. So b plus 5, b minus 3, sorry. So 5b, positive 5b and negative, that will give me a plus 2b. The answer will be b equals to negative 5 or b will be equals to 3. In this case, I can see minus 5 will be on this side. Okay, so if minus 5 is on this side, I'll have a problem. Which means that my b there should be the positive value there, because that value there is on the positive side. So b will be 3. So therefore, I can just say b will be equals to 3. Right? So that is my upper limit. So I'm going to write now my upper limit will be equals to 3. So I'm going to just write this an upper limit, which is going to be equals to 3. Nice question. And these are the type of questions that you sometimes get in an exam, whereby sometimes they'll say find the lower limit. You must then know what to do. The basic thing here is to first write the integral. Right? Once the area is given, then equate to the area. Okay, so that is very, very, very important. So that is a very, very, very good question. Right. Now here is activity 7. We are also going to find the area here. But with the area, it's a very different question here. How am I going to get the area of this? So first of all, if I look at this is from minus 2 to 2. This is the symmetry. In other words, this part here is the same part, will have the same area as that. But this area is above the x-axis. This area is below the x-axis. And we're going to find same answers. But if I'm going to use that method and say this bracket minus that bracket, I'm going to get 0 because of the symmetry. So this part here, the area of that part and that area of that part will be 0. So what is the easier way to do this? I'm first going to call this one area 1 and this one area 2. I can still do it with even with the ones without any symmetry. If I take the area of the top and the area of the bottom, the area that is part of the top and part of the bottom below the x-axis, and I add them together, then I'll get the area of the whole. All right. Now, two ways of doing this. First of all, I'm going to get the area of from 0 to minus 2. So in other words, my upper one will be 0, my lower one will be negative 2. Area 2, I'm going to say O from 0 to 2. The upper one will be 2, the lower one will be 0. So I've got two options. First, I'm going to write my integral. The upper part is 0, the lower part is negative 2. So I'll get 3x squared cubed minus 12x of dx. The other one that I'm going to do will be the upper part is 2, the lower part is 0. So same thing, 3x cubed minus 12x of dx. So I'll do two of them. Now, first of all, I'm now going to substitute. I'm going to first derive. When I derive, I'll get 3 over 4 x to the power 4 minus 6x. As I say, by now everybody must know how to integrate. So we're adding a 1 here, it's a 4, and then divided by the 3 plus 1, which is a 4. We're adding a 1 there, which is a 2. This is squared, sorry, which is a 2, and then from there 2 times 12 divided by 2 will be 6. Top value 0 minus 2. So that one I've just written it in here. We're going to use this one now for the other one. So from there I'm going to substitute by 0. Minus substitution by negative 2. Right? So if I substitute by 0, I'm going to get 3 over 4 substituted by 0, and then I substitute that one by 0. Then this side I'm going to substitute by negative 2. So I'm going to have 3 over 4, substitute that by negative 2 to the power 4. Minus 6 into 2 squared. Right. In this case, this side I'm going to get a 0. That side, if I use my calculator, I'm going to get a that is 2 to the power 4. It's 16, and that will be 12. I'm going to get a 12, a 24 there, and minus 2. I'm going to get a negative 12. So I'm going to get positive 12 units squared. So this I'm going to call it area 1. Area 2, so area 1 is 12 square units. Area 2, same thing. So I'm going to say this 3 over 4x to the power 4 minus 6x squared. This is now the upper part is 2, and that one will be 0. So if I substitute this, I'm going to get a 12 minus a 0. We've already worked it out here. If I substitute by 2 there, if I substitute by 2, this is negative 2, sorry. If I substitute by 2 there, I'm still going to get that same value. So I'm going to get 12 minus 0, and 12 minus 0 is 12. So I'm going to get 12 square units. Therefore, the total area will be A1 plus A2. Area 1 plus area 2. And this area 1 plus area 2 will give me 24 square units. So the area of that is 12 square units. The area of that is 12. It's 12 square units. Remember, we're talking area, so area cannot be negative. So if you get a negative number, then you make it a positive. You're right. Therefore, area will be 12 square units, not negative 12 square units. So we get 12 square units for the first one, 12 square units for the second one. Because if I've done it with 1, and I had 3 over 4 x to the power of 4 minus 6x squared, and I say 2 and minus 2, and I subtract that, my answer was going to give me a 0. And we can't have an area of 0 when we have those two shaded area, and we say the area is 0. If I've done it like that, I would have got 0. So if I've got that as a symmetry, I know it's 0 to 2, 0 to negative 2, 0 to 2, it's a symmetry. So that is a line of symmetry. Then we have to do some miracles there, and if you get something like this, you must then know. Get that one as area 1, another one as area 2, work them separately, get those two answers, add the two answers, you get the area, the total area of the whole thing. Okay. We just want to quickly do the preview of the next lesson. The next lesson will be on the 16th of April 2025 All our lessons start from 2:30 to 4 o'clock. The topic that will be done next week will be trigonometry. Please prepare for it. Really want to take this opportunity to thank you and welcome back again to term 2. Thank you.